strange lines, vertical and horizontal lines. So although they don't fit into our classic linear model, it is important to understand how to write equations for both of those lines. And actually you're going to see that they're pretty easy. So it says never forget though that when we create an equation for a curve, okay, any curve, a line, it simply describes all the points that that curve shares in common. So it says shown below are horizontal and vertical line. So this first one, we've got this horizontal line here, and it says write down 2 coordinate points. So let's pick those 2 that are on our graph. And the first, that point on the right-hand side is 5, 4, and the point on the left-hand side is negative 3, 4. So putting those down. And then the second question says, what do they share in common? Well, you can see that they share a common y, okay? A y that equals 4. That's what they share in common. So what is this line's equation? You just wrote it, and you didn't even realize it. Y equals 4. So it doesn't fit our standard linear model, but it comes close. So some information about this. When we think about our standard linear model, which is y equals mx plus b, you have a y here, okay, that y equals 4. But what are we missing in this equation? We're missing an x. So therefore, what would the slope be of this line? Okay, there's no steepness to that line, so the slope is 0. So hopefully that makes sense to you, that y equals 0x plus the y-intercept of 4. Well, that 0 times x isn't necessary to write, so 0 equals 4. So that's the reason behind that one. Now let's look at this second one, and it says write down 2 coordinates. So 2, 4, and 2, negative 1, and they ask the same question, what do they share in common? Well, they share an x equals 2 in common. So therefore, you just wrote the equation of the line, x equals 2. So again, it doesn't fit into that y equals mx plus b form. So let's think about the slope of this line. Okay, the slope of this line, if we were to do rise over run with those 2 points that we are given, you would end up with a 0 in the denominator. It doesn't matter what you would end up with in the numerator, but a 0 in the denominator, can you ever divide by 0? And your answer should be no, that's not possible. So therefore, the slope of this line is undefined. Okay, so you have an undefined slope there. So again, a little bit of background as to why these equations look a little bit different than what we're used to. So they're super simple, but as time goes on, for whatever reason, kids get them mixed up. So try to keep your thoughts that the horizontal is y equals some constant, and the vertical is x equals some constant. So which of the following equations represents a vertical line that passes through the point 5, negative 3? So the key word there, vertical. So if it's vertical, it's x equals, and what is the x part of this point that the line would go through? It's 5. So x equals 5. Go ahead and flip the page. It says it's important to be able to quickly and accurately graph vertical and horizontal lines given their graphs. So let's become fluent with this, meaning they should become pretty easy to write. So we've got this vertical line in A, so when it's vertical, it's going to be x equals, and what's the x value that it goes through? 1, 2, 3. So all the points along that line, whatever the coordinates are, the x part of the coordinate would always be 3. Letter B, again, it's a vertical line, and what does it go through? 1, 2, 3, negative 4. So now letter C is horizontal, so it's y equals, and what y value does it go through? -1. So again, all of these points along this line, whatever the coordinates are, the y part of them, the x's will vary, but the y's will all be -1. That's what they all share in common. D, vertical line, so x equals +5, y equals +4, and again, another horizontal, y equals 2. Write an equation of a vertical line passing through the point. So that vertical is always your x equals. And what's the x value of this point? -4. And a horizontal line passing through the point 3, 2. Horizontal is your y equals. And what's the y value? It's 2. Down here at the bottom, we've got three equations that they want us to graph, and then we're going to see that a triangular region is going to be formed. So that first one, y equals 2x minus 4, so my slope is 2, and my y-intercept is -4. You certainly could graph this on your calculator and get a table of values. I'm just going to use slope and y-intercept. So my y-intercept is -4, and then rise over run, up 2 over 1. And put a fair amount of those points in. And then I'm going to use a straight edge because I'm eventually going to have to calculate the area that's formed by these 3 lines. So I want to be as accurate as possible. And now x equals -1. Well, x equals -1 is going to be that vertical line going through where x is -1. And then y equals 2 is a horizontal line going through where y equals 2. And they are encouraging us to make sure that we label those. So y equals 2. Whoops. Y equals 2, if I could get that to label properly. There we go. X equals -1, and y equals 2x minus 4. Sorry about that. A little trouble with my stylus. Oh, seriously, it just moved. All for a label. There we go. All right, so now they want us to find this area that's enclosed by these 3 lines. So area formula for a triangle, 1/2 base times height. So we end up with 1/2. The base of this triangle is 1, 2, 3, 4. And the height of it is 8. So 1/2 of 4 times 8 is 16 is my area. All right, see you in class tomorrow.